welcome everyone. Let me go ahead and get us started. So my name is Jasmine and I work for AAS as the meetings coordinator. As a reminder, this session is being recorded. You'll be able to access it within 24 hours or in for 30 days for after the meeting concludes. We do have a hard stop at 1:29 because we have a webinar right after this one, but you will have time to ask questions. You'll be able to unmute yourself or put them in the chat box and we'll read them out loud. And with that, I'd introduce our speakers for this evening. We do have three. So first we have Ed Chambers from SOFIA, Louisa Rebel from IPAC, and then we have BG Anderson from SOFIA as well. And I don't know if anyone wants to start sharing their screen, test that out.
Ariel, did you want me to start?
Yeah, I think we said
okay,
UBG, then Ed, and then Lisa. I think so, yeah.
So I'm hoping you see my screen presentation now.
We are.
Yes.
Good, thank you. So thank you everyone for coming. We're going to be presenting a bit about the active archival research program call that's on the street right now for using SOFIA data. And I will give an initial discussion here first about the mechanics, if you wish. So we're of course about to start in another few months the 9th full cycle of SOFIA observing, and there are now a good number of very good data sets in the SOFIA archives, some of which are unpublished and some of which there are synergies that you can take advantage of. And of course, in parallel to generating new and exciting observations, the SOFIA pipeline and pipeline processing have been progressing over these years. So there are updated data sets in there as well. So there are many sources that also have been observed by different instruments, but from different PIs, and there are synergies to be explored in there. And also, particularly in the early days, there may have been programs where the original analysis did not succeed for whatever reason, but where renewed efforts and renewed data products can lead those observations to publications. And so for these reasons and others, SOFIA has issued a call for funded archival research, so you can get money in addition to good data. So the archival program, this is the second time we've issued an archival call. The first one went out with the cycle 8 call simultaneously. This one is a standalone. The call for proposals was issued in early December, and we have a proposal deadline in February coming up in several weeks. There are two types of proposals that are advertised in the call. There's the regular ones, which we envision to be the sort of standard, same as observing proposal, or maybe even somewhat bigger projects. 2 years nominal duration, funding nominally up to about 150K. We have also explicitly included a category of small programs, maybe targeted observations, and also explicitly intended to allow junior early career scientists, including graduate students, to have their own programs. And those are nominally 1-year programs with funding limited to about 50K. And just as a formality, in many universities, institutions, graduate students are not allowed to be formal PI on funding proposals, but we just ask you to use the functionality in the SOFIA proposal call of you as lead investigator for a faculty member to act as the formal funding PI there, but the grad student is allowed to be the science PI from our point of view. We made a clarification at the end of last week for the call to note that also for the small programs, we will need a simple budget, which was not quite clear in the call as we released it. It doesn't have to be very formal. It doesn't have to be approved by your SAR, but it has to show how you intend to use the funding. So of course, there are other archival data programs within NASA, and specifically the ADAP. And there is no formalized discrimination or delineation between the SOFIA SARP and the ADAP, but it's clear that you can't propose to do the same thing in both proposals, so you should probably pay attention to that. And as with the Cycle 9 observing call for proposal, we at the SOFIA Center are doing this archival call using the dual anonymous review process. And you will see that when you go on to the USpot tool to submit your proposals. And as with any earlier cycles, we are using the USpot tool for ingesting these proposals. So a few more clarifications, explanations. The call is open to all US affiliated scientists. This is of course somewhat goes without saying in the sense that this is a NASA supported call, and NASA does not send money outside of the US. And the data that we're talking about here is the open archive. And so therefore, it makes no sense for non-US astronomers to propose to this call. So that's the limitation there. Even if you were the PI on the original proposal for the SOFIA data, you are allowed to propose for the SARP for that data. Now, it has to be clearly justified why it is you need more data, more funding, sorry. And the funding for the original observing program has to have been closed out. So you cannot have concurrent proposal money from the original proposal and from the SARP program. Supporting work, both some observations, analysis of supporting data, and some limited amount of theory is allowed under the call, but it has to be direct support, and it has to be reasonable. And because this is a funding proposal, of course, the cost efficiency of the proposal will be part of the review. So you can read more details about what here is and is not allowed in the call. As usual, now particularly with the DAR process, the proposal will need to be submitted in two parts. One science PDF attachment to the USpot where you have anonymized yourself and don't tell the world and the reviewers who you are or where you're from. And then a second PDF attachment that contains the team and that kind of information. The initial TAC review, I shouldn't say TAC here, but the initial review will be done anonymized, and so the reviewers will not know who you are until they have formed an opinion about the science content of the proposal. We will then de-anonymize the proposer team and give the review a chance to comment on any relevant issues about the feasibility of executing this proposal in a timely manner. And I already said this, we ask you that you do take the effort of anonymizing your proposal Don't try to sneak in a lot of self-citations to hint that you're a proposer, and try. We won't. We're not gonna nitpick on you, but do try to help us with this. It turns out the DAR process works really well, so please help us with that. And with that, I'm going to just put up a few links here of interest, but I think Marielle will come back to these in a bit, and I'll let Ed take over from here. So I'll stop sharing, and Ed, please go ahead. You're muted.
All right. How's that look? Okay for everybody? All same yes. Good. All right. So my name is Ed Chambers. I work with the data processing and the science archive teams at the SOFIA Science Center. And for the next few minutes, I just want to show some of the highlights of our science archive at IRSA. So first up is an image of our Galactic Center at 25 microns. This is obtained with our forecast instrument. This image, along with another one at 37 microns, were taken as part of Matt Hankins' legacy project in cycle 7. It's a really rich data set. It's beautiful, and almost as importantly, it's super easy to access at IRSA. All I had to do to make this slide was download the FITS file, load it into my favorite FITS viewer, and that was it. It's already stitched together, it's calibrated, and ready for analysis. Of course, showing this image also gives me a good excuse to show our beautiful press release image of the Galactic Center, where we've combined the SOFIA data along with some Herschel and Spitzer data for this really spectacular infrared view of our Galactic Center region. If I zoom in on a couple of small subregions of the larger mosaic, here on the left is the quintuplet cluster and the pistol star. And on the right is the circumnuclear disk and the little mini spiral that's feeding material onto the supermassive black hole in the Galactic Center. You see even the detail in these smaller subregions is really quite good. And so if you're interested in the Galactic Center kind of as a whole, or even if just a particular object or a region within the Galactic Center region, I'd really encourage you to download and explore this data set. Moving on is another one of SOFIA's legacy project. This one's titled Feedback. The project's led by Xander Thielens and Nicholas Schneider, and its goal is to study the impact of the strong winds and radiation from young high mass stars on their local environment. And so to do this, we're using the UPGRADE spectrometer, and we're mapping 11 high mass star formation regions in the C+ line at 158 microns. And so since we're mapping with a spectrometer, the final data products are data cubes. But what I'm showing in this color image is an integrated intensity image of the C+ emission from the data cube that I downloaded from IRSA. I'm also showing a couple of spectra that I extracted from the cube to kind of give you the idea of the velocity resolution, which is sub-kilometer per second, as well as the really strong signal to noise. Here's another example from the project. This is M16. And again, just really nice spatial resolution and velocity resolution. You also might be able to tell that these maps aren't quite complete, where the feedback project is something like 30% complete right now. We're continuing to make observations of it. And with these legacy projects, as soon as the data are processed and archived, they're available for public download. There's no exclusive use period. So that's a really nice advantage of these legacy projects. So moving on from the legacy projects, I wanted to show something that I've called project synthesis. This goes back to something BG was mentioning about taking advantage of multiple observations of the same objects across different instruments. What I did was I just went to the archive and plugged in a couple well-known objects and just kind of poked around to see what images I could find that I may not have even been familiar with. So the first of these is 30 Doradus. So this is a massive star forming region in the Large Magellanic Cloud. And on the left is a polarization map from our HAWK Plus instrument. The color is the total intensity, and the small black lines are the polarization vectors. In the center image is from our FIFI-LS spectrometer. This shows C+ line emission along with its surrounding continuum. And then I extracted a C plus spectrum from the great instrument toward a local peak in the FEFLS instrument. So if you're interested in the role of magnetic fields in star formation or feedback in low metallicity environments, then these data are sitting in the archive ready to be downloaded and analyzed. The next object I looked at is Orion, and to be honest, this is a bit of a cheat because I know we have a ton of Orion data in the archive, but it really is a nice showcase of a lot of SOFIA's capabilities. So the center image that you can see is our C+ map of the Orion region. This is over a square degree in size and was taken from over 2 million spectra. So this is a really nice image to look at. We've already had a couple papers about this, but there's it's so large and has such great resolution that we can keep looking at this for a long time. On the left is a Hawk Plus polarization map of is kind of the heart of the nebula. So here is the Orion bar. I don't know if you can see my mouse, but it's on the lower left of the image, and the bright spot is the BNKL object. If you look at the top right is another image from our FEFLS spectrometer. This is CO 16 to 15 emission from the BNKL object. And then there's an XE spectrum around 6 microns, also BNKL, and a forecast 11 micron image of the Orion bar. So as I mentioned, I mean, this is only a subset of the Orion data that we have, but it really does highlight the diversity of data products that we have coming out of SOFIA from multiple instruments at multiple wavelengths and multiple observing modes. So to wrap up this section of the presentation, I just want to point out that we have over 12,000 calibrated science-ready public data products at IRSA. I've included the URL to our search page there on the right side, but it's very easy to navigate to it from the main IRSA page. If you're kind of interested in some more of these highlights from our archive, you can visit the URL I've listed here. This is also, you can navigate to it from our main SOFIA page. And of course, if you're ever having trouble finding a data set, viewing or analyzing data, you can always contact us at our help desk. And during this meeting, you can come by our booth and chat with us there or set up a time for a more detailed discussion. So that's what I have. And I think now I'll pass it over to Louisa, who's going to present some more information about navigating the archive at IRSA.
So I'm trying to inoculate myself against internet hiccups. And so I have a 4.5-minute video here that hopefully will just work.
Here's a quick introduction to the SOFIA archive. The IRSA main page has a link to SOFIA, but also note that it has a video tutorials link down here and the help desk. The video tutorials link describes how we organize our tutorials and has links to the playlists that combine a bunch of videos on a similar theme. SOFIA is here. We go to the SOFIA archive. And the most common search is probably going to be a position search. So you can put in the position of the thing that you want. Note that you can search on a list of positions, a solar system target, look for any serendipitous observations of a solar system target, or do a search over the whole sky. You can add additional constraints like the proposal information, the observation information, including observation date, instrument constraints. You can limit the search by wavelength or by instrument. And you can search by data product constraints. Level 0 and level 1 are the rawest level of data. Level 3 and level 4 are the highest, most processed level of data. For this example, I'm just going to leave all of this as the defaults and search. This is what the search results look like. The tab that's on the top is an AOR tab. It's the most compact view of the observations. It found 100 observations that met our search criteria. If you want to see these depicted on the sky, if you pick the coverage tab, it shows all of these polygons on top of the sky in near infrared. All those polygons correspond to all of the observations that it found. Each of the instruments we requested has a tab in the results. If you go to the XEs tab, you can see that it found 657 data products that met our constraints. The data tab here renders the specific observation that's selected. In this case, it's a mask file, so it's not terribly interesting. But this data product is this spectrum here. You can click and drag in the plot and then filter. And then the plot zooms in You can also view this as a table, and this table, just like this one, has the ability to filter. Here you can see the filters that I imposed from the plot. To cancel the filters, hit the Cancel Filter button. You can go back and view it as a chart. You can also make the chart big. Let's go back and look at some of the other data products. FIFI-LS has a bunch of data products in here. We asked for level 3 and level 4. Remember that level 4 is going to be a higher level product. So let's pick level 4, filter. Now it's showing the data product here on the right. There's several different HDUs, and within each HDU, there's several wavelength planes. You can use the arrows to navigate, or you can type in a number and jump to that plane. You can also use this menu to pick which HDU you want to work with. FlightCam has images that are shown here. Forecast has images that are shown here. For both FlightCam and Forecast, these are FITS images, and so you can interact with the FITS images using this toolbar on top. There's another movie in the IRSA YouTube feed that talks about what all of these do. FBI Plus doesn't have any observations on M42. Great has lots of observations. The red rows are proprietary data, so unless you're logged in and have access to that program, you can't preview or download that data. This data product is public, and so you can see a preview of the spectrum here. Here too, you can view it as a table or a chart. You can also view the other spectrum that is in this file. You can also, if you really want to, look at all of the images in the file as images. For some of the great data, this particular file is a FITS file. If you go to a tarball, the tarball can't be shown in the data tab, but there's usually a preview that shows you what kinds of data can be found in that tarball. Hawk also often has previews, but you have to pick the right kind of data. Let's limit this to level 4 data. There, it's got a preview of that data. For some of the data products, you can get a preview of the data here. And here you can scroll through the planes, or you can pick the planes from here. To download data, all you have to do is click the tick boxes at the beginning of each row that you want. Or if you want all of the data, click the tick box at the top. Prepare download. Depending on the data product, you may want the PNGs, the preview images that come with the data, or you might want any region file overlays. You can choose to have the data structured, in other words, lots of subdirectories or no subdirectories at all. This is where you put the file name that it's going to use for your local disk. You can save it on your local disk or on the IRSA workspace. If you're downloading a lot of data, I recommend turning on email notification. Then when all the data are packaged up and ready for you, you'll get an email with a list of links to download all the data that you selected.
Okay. Are there any questions for the operational side of things, or do you guys just want to go for questions for all of them?
Oh, I'm on mute. It's up to you all. We can just do questions for everyone. It looks like Anthony has his hand raised. So, Anthony.
Hey there, guys. Just a quick question for you about the PI instruments that you have there. Typically, what you would have to do is add an investigator from that PI instrument for regular proposal. For archival proposals, are you expected to do the same thing, where if you picked a great project from the archive, you would then reach out to someone from the great team to be included in the paper if you either write the paper, or do they have to be in the proposal that you write for the archival search?
Let me start on that and see if Margaret or Jim wants to comment on it. That is a rule that's instituted in the call for proposal for observations. So these data are public, so there is no requirement that you include anyone from the PI team. You may want to do it for help, support, expertise, etc. But there is no requirement in the call that you do this. These data are public.
That is correct. I just want to confirm that, BG, that is correct. That the synergy basically. So if you were an original investigator on the program, I mean that the assumption is that co-authorship was done there at that point. And now that it's dumped into the archive, this is sort of reuse of that data by anybody.
Okay. Can I ask one more follow-up question to that, please? Okay, did you say no?
No, no.
Oh, the follow-up question was, I'm intrigued by the, if you haven't, if you are encouraging student writing proposals and getting time. I know that you guys were showing a little bit of my great data there. Thank you. And if a PI is a graduate student, could they be of a proposal you already submitted? So can my graduate student then be a proposal for this archive on a project that we may have already submitted, got funding for, but never actually were able to publish the data for one reason or another?
Yes, as long as two things are fulfilled. One is that you justify why you need the additional support and what you're going to do with it. And two, that the original program has been formally closed out.
Okay. All right, I think it is. All right, thanks.
Any other questions? Ariel, do you want to add something?
I don't see any question on the Slack channel in case there was some there.
I've got a question. For the legacy projects that are still being observed, such as feedback, does the data that we propose to use have to already be in the archive at the time that the proposal is submitted? For example, if there is data that is expected to become available.
I think the answer to that is that because of the very real constraints in SOFIA observing, if you project data that don't exist in the archives, your proposal will be significantly weakened. So we haven't explicitly said in the call that you cannot ask to work on legacy data that you quote unquote know will become available, but because it's not clear exactly when those data will be there, you would have I think you'd have a weakened proposal from that. Does that answer your question?
Yeah, thanks.
All right, it looks like we have about 30 seconds to the 1:29. I'd like to thank all of our three speakers for this evening and want to wish everyone a great rest of your evening.
Thanks for your support, Jasmine.
Thank you.
Go propose.
Yes, BG, whatever you say, BG.
Thank you. I'm putting on my Army captain hat here. Go.
Oh, captain. I'm thinking more general for you, BG.
No, I only made it captain.
Okay, all right. Okay, we'll call you a colonel. How's that? We'll fit somewhere in between. All right, take care.
Thanks, everyone.